Hey everyone. Let's see. Okay, I think we're up and running. I'm just gonna wait a little bit, wait for people to join, and get everything. Okay. Getting faster at getting things set up. We'll wait a little for people to come and join. We're going to continue what we were doing yesterday. And what we were doing yesterday was basically trying to create, let me show you. We were trying to create a CNN to solve this question. So it's basically make a neural net on MNIST that gets over 85% accuracy. We don't really need a CNN, but you know, we're gonna do it anyways, just because. Still trying to get set up. There we go. We don't really need a CNN, but it's more from the learning perspective of I want to do it. Today I'm drinking this thing, lemon, ginger, and pineapple. Not terrible, not that good, but mixing it made it all worse. By worse, I mean more intense. Let's keep shutting off. Okay. Let's get started. So, before I get into this, I'm doing this just more because I'm curious. We're running a 2025 paper madness, so we're pitting different papers from the year against other papers, and we're basically running the results on X, or running the polls on X. So let me just go to my profile. You could see all of the voting and all the results. One thing crazy, one upset, is gated attention's beating the Kimi paper. But we'll see. I mean, yeah, DeepSeek is destroying. DeepSeek is the #1 seed, so we'll see how things. Oh, you had included the seed numbers for the second one. I did not. Okay, but I'm curious to know what's the best paper of the year. Hopefully, we get a lot more votes and a lot more people interacting with it, because I feel like it's a pretty interesting concept. At least according to me, we have LLM and reasoning division. We have the computer vision division. Computer vision division, yeah. Autonomous agents, and we have just math division. Yeah, so just be on a lookout for any of those. It'd be great if you guys just vote on things. It'd be amazing if we got Polymark, whatever the name is, to to host the betting on it. I don't think a lot of people would bet on it, but it would be nice. Okay. I feel like I stalled enough for a few people to join. So yesterday we did this question, we solved it. Very nice. Solution should be here. We have a nice solution about just implementing the forward pass. Now we're gonna have some more fun, and we're going to implement the backward pass somehow. So this one might. We'll see if I can finish it all in this stream. If not, we'll do multiple streams. But this one should be a lot more fun. We went to simple CNN. Simple, guys. Guys, there's nothing to worry about. It's so simple. Training function with backpropagation. Okay. Create a function that trains basic convolutional neural networks Using back propagation, the network should include one convolutional layer with ReLU activation followed by flattening dense layer the softmax output. And the cross entropy loss. Yeah, we're gonna have some fun. We're gonna have some fun with this one. You need to handle forward pass, compute the loss gradients, and update the weights and biases using stochastic gradient descent. Okay, at least just regular gradient descent. Ensure the function processes the input data as grayscale image, one hot encoding labels, and it returns the trained weights and biases for the convolutional dense layer. Let's see what the example looks like. So we take in X, some array, we take in Y, which is the prediction of the results, and we get a few other inputs. I'm assuming that's learning rate. Let's see what the other things are. Oh, epochs, learning rate, kernel size, and then number of filters. Okay. I don't know why I'm so scared of I'm so scared of even starting this. Just like it's the, I don't know. It's just the fear of, because I know what I'm getting myself into, but trying to think also what would be a nice way of doing this. It doesn't look so bad. Let's try and do it, because every time I try to do it differently. Let's do it. Sketch Scala draw. Okay. Here's the plan. We are going to learn section. Learn section. Then we are going to do problem breakdown. Then we're going to solve. So doing, in the learn section we'll learn what's actually going on, and we'll draw some pictures here. How I'm dreading this. Okay. Understanding a simple convolutional neural network with backpropagation. A convolutional neural network. Okay, CNNs learn two main things. Okay, so it takes a small chunk, looks at that chunk, and learns by applying a filter on what actually to look at. Okay. Okay. I mean, just for, I wish I had my old images. So let's say this was an image. I know I did this last time, but we'll do it again. Okay, so we have our 4x4 image. I'll do this quickly-ish. It's a grayscale, so there's only one dimension. If it's a colored image, it has 3 dimensions. I wonder if other images have more than that. Like if you use, I guess they do. Like infrared imaging, is that more than 3-dimensional? Okay. I get angry at that drink every time I try it, but every time it looks good, I'm like, oh, lemon, ginger, pineapple, that sounds nice. And then I drink it, and I'm like, I don't like that as much as I thought I did. Okay. So, we will also have, this is a filter, or a kernel, and this will have a set of numbers, and it will go over this, and let's say this stride is 2, it will go here, it will go here, and it will go here. So we'll go through all of these. I'm assuming it'll fit perfectly. So we have this. some random weights, 0.2, 0.4, 0.45, 0.11, whatever. Let's see if we can make this actually look decent. So let's say we have it here, right? And then there's other numbers underneath here, but whatever. So we take this. This gives us some output. When we run it over all of these, we get, in our case, a 4x4 output. We'll just take this really simple. Let's assume there's only one filter layer. Pretty sure that's what it was called. Okay, we do this. We have our results from, this is the result from running the full convolution. So here we get one number, it goes here. Here we get one number, it goes here. Here we get one number, it goes there, and so on. So we get our new thing. This goes into a little network. And then however many classes there are on the end. Let's say there's 3 classes. There we go. Faster. This would have taken too long the other way. Whatever, you know what I mean. You have a neural network and it puts out the outputs, and so it gets flattened through a network, puts out the outputs. So these are outputs. And from here, we're going to get the loss. Once we have the loss, we're basically going to need to back propagate it through all this junk. If this question is too annoying, we might start with the regular neural network with backprop, but let's try and solve this and see how far we get. Okay. The basic structure of what we're doing. Okay, learn section. Let's read it quickly. Okay, so we have the convolutional layer that does. So you have some layer X. What is this? Convolutional layer slides a small filter over the input and produces a feature map. So we have our filter, as we saw before, we roll it over X. And then I guess these are the weights associated with that filter, plus some bias term. Even building this is going to be annoying, but let's continue. This result in a shape tensor, blah, blah, blah. Just trying to understand the concepts right now. We'll get into everything later. Where H and W are the input height and width. K is the kernel side, F is the number of filters. So in our little fun example, this is just one filter, but in reality we could have any number of filters. Relu activation, okay, it's the max of, we know that. Flattening. Dense layer. I'm really hoping the problem breakdown is good for this one. Oh, an example. Nice. So we have some value x, we have some kernel this. So it would go what here? I don't know what the stride is. Oh, did it not provided a stride? Let's see. Kernel size is 3x3. I'm not given a stride. Do I just assume I have a 1? I'll assume The stride is 1. Let's continue. So 1 times 1, yeah. 0 times 2, 0 times 4, 1 times minus 5, correct, and we get minus 4, so that would be the first one. After ReLU, it becomes 0. I mean, we'd run this against all of x, not just the first one. Okay. Let's do problem breakdowns. This is a premium feature, but it is free for, on the daily question, whatever that is. So you can still use it. Okay. So we have some weight convolutional layer W. They want us to slide it over the X. Compute the dot product at each valid position and zero out negatively. Okay. Let's start to do this and see. Okay, this is really simple. So you have X. X times W, so conv, and then we take np dot sum this, and this gives our output, np dot max 0 comma out. Let's see if I get this right. I did not. Expected minus 3. Axis minus 3. Let's see. It's out of bounds. So given some input x, and we're given some. Fine. Oh. Also given bconv. Which I'm not sure how that. It's plus b? Sum all of that? Let's get a single. Let's see. Did I lose my work? Ah, submissions. Fail to load submissions? No. Luckily I didn't work so hard on this, but I need to fix that. What are we doing? We had x times w underscore conv. Always listening to music when I stream. I feel like it makes the whole process better. Okay, that shouldn't be right, but let's just see if things are working. Should be able to go to notebook mode from here too. B is not defined. That is a valid complaint, my friend. Because now I want to use my notebook mode while I'm breaking down questions. Okay, minus 3. Okay. Oh, maybe it was just complaining about. Okay. Okay, now just complaining about the style of everything. There. Happy. Okay, but yeah, we got it right. Let's go to the next one. Let's see if solving these will actually help us solve the main question. Oof. I'm a baby when it comes to ginger. I don't know. It burns. Also, gotta wearing the Deep ML sweatshirt. Gotta represent. You've been saying let's continue. Take the flattened feature A flat. Compute the logits via matrix multiply plus bias and convert. Okay. Just given some. Yeah. I don't know why I read that, but I didn't really read that. So we have a flat dimensional thing. Compute the logits, whatever it is. Okay, so they want us to get the logits from A flat, W this, that. Okay, so it's just a regular. Should just be A underscore. I don't think there's going to be enough problem breakdowns for this question, just based on we're going through the pretty easy stuff, or the next two are going to be really tough. W dense, I feel like it's transpose plus B underscore den. I feel like this is what it is. Let's see if that would even make sense. I mean, this is a 2x2, so it won't really matter, because transpose is still 2x2. Oh, hey. Thanks for joining. Yeah, anyone want to chat about anything? Someone said, please reply. Hi. Let's see. Let's continue. Where were we? I think this should work. Basically thinking this. Just thinking about the matrix multiplications. So this is 1 by 2, and this is a 2 by 2. So if we take this, it should be a 1 by 2, and a 1 by 2 is the same structure as this, so this should work. This should work, and of course it didn't. Oh. What did it want me to do? Oh. Probably vector with softmax. Okay, let's see if I remember. I think I remember softmax nicely. I didn't see that. I mean, it's not stable softmax, but it's softmax. So the exponential of each value divided by the sum of exponentials. Pretty sure this should work nicely. Yee. Okay, we could do the forward pass, which I feel like I know I could do. The backward pass, which I'm hoping is this. That's what I'm scared about. Compute the gradient of cross entropy loss. Okay. Compute the gradients of the cross entropy loss. Let's see. See, sometimes I just get, I'm just like reading it, and I know I just need to take it in small steps, and like that's why I made the problem breakdown, because this is something I needed, because I know I try to solve everything at once, and you gotta just solve things in smaller steps sometimes. Okay. Compute the gradients of the cross entropy loss. We're given A flat, A dense. Let me read this, and then I'll get to your question in a sec. Let me just read this. Let me answer the question, why not? Seem very indecisive. Let me finish reading the example, understand what we're sort of doing, and I'll answer the question in chat. So we're given an input A flat, that's an input we had before, we're given A dense, we're given Y, we're giving W dense. Okay. So we're just trying to compute the gradients of this process. So there's the weights. So if I take some derivative of this, derivative of that. Okay. I'm pretty sure that computed. Okay, let me read the question quickly. What do you think about the Fast AI library for a complete beginner in 2025 for getting his first overview of MLDL? Do some Kaggle data sets using Fast AI, and then go traditional ML, scikit-learn, and PyTorch. Please tell me your opinion. I mean, my opinion, I think I said this a while ago. I mean, if you like to make sure you actually like learning through Fast. I think Fast AI is an amazing tool. It teaches. Wait, no. What was it called? Is it Fast AI? This wasn't it. Oh yes. There's his face. Yeah. I think it's an amazing course. Yeah. I really like Fast AI. Hold on. Sidetracked a little. I really like it. I think it is an amazing course, but make sure you like to learn that way, because there's a few different ways you could learn. You could learn the traditional way, and that method is pretty good, especially if you like. Let me see. Let me finish this idea then. I need to check on something. The main issue is some people don't like learning like that, and that's completely fine. Some people actually like learning that way, and you just sort of need to figure out the type of learning you like. Me personally, I try to like. I feel like it's a pretty cool way of learning. It's project based, so you pick a project, and from there, you basically Google or ChatGPT and learn the things along the way once you get stuck. So the process would be project, get stuck, learn. And this won't teach you how things actually work. Like DeepML will teach you how, you should use scikit-learn, use any library you want, get this done, build a cool project. And once you have the cool project that you actually find interesting built, then you could start diving into some of the things you didn't really understand. So maybe you did, stock prediction or something like that with, linear regression. But you don't know how linear regression works, so you could go to DeepML or you could go to any other site. You go to Fast AI. Like I'm saying, build a project, learn the stuff. Then I'd say get to the gritty details about how things work. But that's how I would theoretically, if I had to redo this whole learning thing, I'd probably do project-based, I did it, me personally, I read Hands-On with Machine Learning, what's it? Hands-On with Machine, I read this book. I read the first edition of this book. Luckily, the second edition came out relatively quickly because I finished the first half, which was just machine learning. The second half was deep learning, but the deep learning was in TensorFlow v1, so it was a lot different than today. But I really like this book. So If I went back, I'd probably do project-based, and then maybe read a book like this or go through Fast AI, just to understand things more concretely and understand what you're really building. Um, because if you find something interesting, then you'll be able to get through the boring stuff. Uh, and I think the interesting thing for a lot of data scientists and machine learning engineers is, predicting stuff, making predictions. Okay, I gotta go for a second, but I'll be right back. Sorry about that. Sorry about that. My baby couldn't really sleep. I got him down. I'm pretty good at, at getting back to sleep. Took me a second, but I did it. I know everyone was wondering where I went. Okay, let's get back into it. Anyone else, let me know if you have any more questions. Let's continue with our actual solving of this question. Delicious. Okay. Compute the gradient of the cross entropy loss. A dense minus y. Okay, so this is the prediction, right? Because this is A dense, which I'm assuming is the predicted values, minus y, which is the actual values. Okay. This doesn't tell us, let's go back to the learn section. It doesn't tell us, where is it? Dense layer, cross entropy. 100 coding level y. Got cross entropy is the sum over. Let's go here. Let's grab this. Okay, so we have the sum over y, and y is going to be, I guess, a 100 encoding, if I'm not mistaken. Yeah, 1 is a 100 encoding. So we have a bunch of values like 1, 0, 0, 0, 0, 0, 0, whatever. And then we're also going to have some prediction, which is going to make it black. Just going to have a similar thing, 0, 0, 0, 1, 0, 0, 0, whatever. So this is actual and this is predicted. And we're going to take YC. What is C? So we will do so let's take the first example. So we have, y1 equals 1, and that's basically times, and then we have y hat equals 0. So what would this loss give us? YH equals 0. So we would do 1 times the log of 0. No, right. And log of 0, I think, is just sure it's undefined. Yeah, I was pretty sure that was the case. So this is cross entropy loss. Okay. I'm doing that right, but I guess because we have zeros. I mean, let's say it's not zeros, it's just very small numbers, because then it would work. 0, 0, 1, this would just be a high number, and obviously you want something high here because, we got the wrong prediction. The next one, we have 0 and 0, right? You know what? Well, we're going the long route. We're going the long route. Screw it. I'm trying to do things quickly. We're gonna go as long as the route is, I don't know, the longest route I could find. Cross. Entropy and cross entropy. Do I have cross entropy? Multi-class cross entropy loss. Yeah, I mean, screw it. I mean, I keep on trying to take small shortcuts, and we're gonna do everything. This is my function, and this might, again, I don't think this is gonna be a 1-parter, 2-parter, 3-parter. Hopefully we'll finish it before the end of the month. That's the goal. And one function that computes the average cross entropy loss of a batch of predictions, multiple class classification task. Okay. Yeah, so here's the thing. It's the predicted probability, and C is the number of classes. To implement the function that computes the average cross entropy. I mean, that makes sense. Let's do this. Predicted probabilities, true probabilities, epsilon. Why do we have an epsilon? Ensure that you handle numerical possibility by clipping probabilities by epsilon. I don't. Let's see. Maybe this will answer my question about what do we do with zeros. Small epsilon. Okay, yes. Okay, I was right. For numerical possibility, add a small epsilon to avoid. Fine. So okay, this should be pretty quick. So we have true labels. True labels. This is an array. Times np.log of predicted probabilities. Plus a small. Oh, that's really small. And this should give us cross entropy loss, but we want average cross entropy loss. Got the first one right. Just 0. What did I get wrong here? So it should be this times this. Oh, do we have batches? No, okay. Compute concentration predictions, true are passed in. And what's 4? Let's see. Is it negative? Oh. And the concentration formula is negative sum of this. Go back to. I feel like I'm doing this right. Assuming I can't just write negative. No, I can. I'm still getting the wrong answers. Let's see where I'm going wrong. The sum. Oh. Oh, it's the sum and then the average of them. Fine. Sum of this. Set another parenthesis there. Still got it wrong. But we're getting closer. Okay, so this is the mean right here. This is the sum of y and c. Let's go to notebook mode. Grab my solution. Okay. Okay, let's go to a real question. So this should be, let me zoom in for you guys, sorry. This should be 0.2 whatever, which it feels like it's this divided by 2. It is. Okay, we're getting somewhere. What am I doing exactly? I wish I knew myself. So right now, I'm still trying to. Probably should open a new tab with it. Let me. The great quest, I'll call it, is solving this question with a CNN, which is basically solving MNIST, getting 85% or above accuracy, using just NumPy. So I'm under the quest of doing this, but with a CNN, I can do it with, a regular network, but less fun. So right now I'm trying to remember what cross entropy is, to be honest, and how it works properly, because I'm gonna have to go through a lot of randomness to get to what I'm actually doing. Right now we're trying to solve this question, which is basically a CNN with back propagation, which will, once we solve this, we're most of the way there. But I was a little fuzzy on the cross entropy loss, so I'm just trying to, I guess, implement this question, which is cross entropy loss. So we might do this a lot. I might go to a bunch of different questions and solve them along the way of solving what I want to solve. Let me know if that makes sense. Okay, so something's wrong. Something I'm doing is wrong. Assuming it's like axis something. It's the old print statements. Forget. Okay, so let's get this. Okay. Oh. Okay, yeah, this is summing everything into one number. I guess it is. I knew it was an axis issue. So many things. There we go. Yeah, now we're getting two numbers, and we average those together. Okay, so let's do this. P sum, comma, axis equals 1. Submit this. Should hopefully be closer. Okay, this is stupid. I mean, it should be. I mean, it should be whatever. It should be -0, whatever. I have to do something. Okay, this is a little annoying. Need to fix up this question a little. Let's see. Solution equals this. If sol equals minus. If solution is less than 0, return 0. Okay. I'm going to check out the solution for this once I actually get this correct. Nice. I want to see what they did to deal with the 0. NV log blah blah. Oh. Do I put the negative on? No, it doesn't even matter if I put the negative there or there. Does it? That might. But it shows it here. Okay, maybe something's off with the learn section. Maybe this isn't weird. But also it's all the same. There's no such thing as -0. I got it right. Okay. Yeah, we're not doing my quest to try and do less shortcuts around things. Where is it? I don't even know what its difficulty is. Hard. I don't remember the category. Where is it? Determine. I don't know. Implement a custom. Is this it? Restart it. Yeah, here we are. Okay. I feel like maybe the PyTorch version should be easy, but let's see what the question is. So yeah, we're gonna solve this, but we're gonna solve this really, I mean, anytime we could use a question to learn something, we can use a question to learn something. So we might have a lot of, that'd be a cool feature. Like, hey, you have this question, solve these questions before. Oh, little stretch. And provide with a base layer. Just implement a subclass called dense, which represents a fully connected neural network layer, the dense class should extend the layer class and implement the following methods. Initialization. Okay, you have the initialization layer. So how many units? Okay, I think that even, yeah, it just gives it to us. Set a placeholder for weights. Okay, give us some of the things. Bias W0. Cool. Are we doing bias? I feel like it would be nice if we didn't have to deal with bias. Did I solve this at some point? I did. I think I solved this a long time ago. I've been busy building this site out more and more, so I feel like I've had less and less time to actually use the site, which is kind of annoying because I originally built the site for me to learn. So, I mean, I feel like now I have the excuse of, oh, this is building out the site because I'm streaming, I'm creating content for the site, while also actually learning. So, thank you guys for watching, and making me have an excuse to learn. Let's see. With initializations, uniform distribution. So uniform distribution with a limit of 1 divided by square root of input shape y. Whatever. And bias is this. Initialize optimizers W and W0. Okay, but I have to initialize them. I think it should just give me the initializations. Okay, but let's continue. Parameter count. Return the total number of trainable parameters in the layer, which include parameter W and W0. I feel like we had a different question for this. What number is this? 40? It might be this one. Let me just see if it actually was that one. Yeah, I guess it was. I think I had one that mentioned Andrew Karpathy's course at some point. Maybe it was in Medium? I feel like I would have put that in Medium though. Let's see. Yeah, this is what I wanted. Single neuron with backpropagation. I guess it's a single neuron, so it's a little easier than a full dense layer. But this is a good place to continue as well. Okay. Again, it's going to be a long journey. So much of me just wants to say F it and just solve the question. Should I just say? Should I just try and solve it? What's the next one? Forward pass, dense layer. That's entropy, cool, backward pass. Softmax. Okay, so let's start with the forward pass, and then we'll work on the backward pass later. Okay. Charge this up. Okay. Okay, so first we need to build out our convolution layer. So what are we given? Let me just steal this. Steal this quickly, and we'll work from here. Or we won't. Okay. So now we have x. What shape is that? A 2. Is that true? Oh. Huh. So we're given. Okay, so these are 3D images, not just our simple 1D ones. Fine. So it's a 2 by 3 by 3. I want a nice view of this. Yeah, okay, that works. So it's a 2 by 3 by 3, so each one number has 3 elements. So it's probably, you know, a black and white image. Just getting everything back up because I have my setup is an iPad on the side looking at the chat. There's definitely a better way than this, but I just started getting it down. So please don't correct me. Okay. So what do we got to do? We got to build a convolutional forward pass first, and we'll start worrying about the backwards pass, which should be fun. So take x, p of I, q of I, assuming p and q. Are not defined, because why would they be? And I can tell them what p or q are. Cools. And then, okay, y is also a one-hot encoding, so that always adds some complexity to everything. Okay, so we're basically doing for I in range. Do we need 3 things? I, j, and k? We do. Let's see. x. Should do this nicer. Wait. Probably should do this nicer, but I don't want to. I think it's 0 of 0. Did do that right. Let's do this. Oh, maybe I did do that right. Hold on. Oh, okay, so this is the I, J, and K. So 0, 0, 1, 0, 0, 2, 0, 1, 0, 0, 0, 1. Okay. Shouldn't it start at 0? Did I miss the first one? Does it cut it off? I feel like it's cutting it off. Because this would be 0, 0, 0. Maybe not. Let me grab X. Did I take the length of that? I did. So, yeah. I think I'm just forgetting. There should be one more above it, which is 0. Okay, this should, we should be able to go through, if I'm not mistaken. If I take X, and I go I, comma, J, comma, K, we should be able to go through the entire matrix, which is correct. Let's see. So now we're going through everything. That's the I, J, and K in this thing. So we're going to need this sum of something, but let's deal with the something first. So we have X. Very annoying how it's not telling me what P is. P plus I, Q plus J times. So, I mean, whatever. We know what we need to do. We need to take this kernel values and go it over everything with it. Put it in 3 dimensions. I always... Yeah. I feel like when it's in 3 dimension, it screws with me a little. We'll figure it out. Okay. Let's at least finish the forward pass on today's stream. We'll deal with backward pass for some longer period of time. Let's start working and see what happens, because we know what we need to do. It's 3 dimensions. What are we given again? Am I not even given a W? I'm not. I'm just giving this. Kernel size 3. I am giving kernel size. So, in our example, what was the kernel size? Kernel size was 3. So, let's say K... Obviously didn't want that. K equals 3. Just gonna see something. Let's do it like this. So I'm pretty sure it is... We want X, the first box of X, to be till I plus K. Starting at I. And this should give us the correct... awesome, good. This should give us the correct information. Let me just make sure this is correct first. So first it would give us these three. Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's just getting this, which I don't think is correct. Why don't I think this is correct, though? Let's draw it out here. So now we have, oh, I could do R, red, green, blue. I think when I could actually make things correct-ish. Okay. So we got our three filters, and they all have numbers. But I'm pretty sure our kernel is supposed to look through all three layers, do the operation like that. It's not supposed to go through blue and then get the convolutions for the blue layer, then the green layer, and then the red. I'm pretty sure it's supposed to be a convolution on all three at the same time. Someone please correct me if I'm wrong, because I don't want to do all this, and I could just do CNN 3D. Should probably add a 3D convolution. I'm pretty sure I'm right. If I'm not, whatever. I'm sure I'll get there. Okay. So k equals 3. So this is wrong. We should... How does k equal 3 even in here? Oh, it might be 2. That would make more sense. What's the order? Learning rate. It's the second to last. Second, yeah, it is 3. Oh, okay. Okay, I'm not right. This was right. I was wrong. Because this, so this is the red, this is the green, this is the blue, red, green, blue, red, green, blue. So we are, so this is the full image of X. So we are actually taking the red, green, and blue for each. Cool. So this looks correct. Okay, so this looks correct. So I think we're grabbing the correct X. Now we need to grab the correct W, and W is currently not defined. Let's say we should define W as something. I'm assuming my weights can be... Probably should say what my weights should be. Okay. We're gonna assume... Sometimes I get caught up in the thought process of, oh wait, I don't understand this one thing. Let me go back to that. And then, like reading a paper, I usually have this issue. I'll start reading a paper and then they'll mention something that, like, you need to know this. And then I'll basically start reading that paper because I'm like, oh, I want to understand it fully. And then you start reading that paper and then there's another thing. It's just a continuous process of digging deeper and deeper and you don't actually solve the thing you want to solve. Now with chat, I feel like you can understand some things high level, and that's fine. Especially because then if you never try to understand, like if you try to understand everything, every single detail, every single molecule, you're never gonna solve anything. Uh, I'm still going to probably go back and do smaller questions sometimes, but sometimes you have to say, you just have to try to solve the question. And yeah, you're gonna feel dumb solving it, and feeling dumb is never fun, but it's a requirement, especially in this field. So go out and feel dumb. I'm gonna make a whole speech about dumbness, how important it is. Dumbness and boredom, really important things. Let's do W. Zeros, size 3. I feel like that would work. Oh wait, what am I? W. No, it's gotta be K by K. Because I feel like, I keep on jumping back and forth, and I hope you guys are somewhat following me. But boredom allows you to get good ideas. If you're always constantly engaged with stupidity, or not even stupidity, if you're just engaged with, your mind's constantly working on something, you don't have time for new ideas. But like if you're, I don't know, just staring at a wall for 20 minutes, no music, no anything, at the end of the 20 minutes, you're going to have a bunch of ideas of anything you could do to that's more enjoyable. Like there's nothing that motivates you more than nothing. And it's easy to get caught up in, using your phone and this and that, and I get caught up with it too. I'm not, I don't think I'm any better than anyone else. I probably use my phone too much, like I'm sure 90% of people, and those 10% that don't use their phone too much, I applaud them, and I'm jealous. Start with this, and then we'll add back in the bias. So, where is... okay, so we get X. Now we're going to need W. Is W... Is W bigger than... No, it's... Oh, but I guess we're going to have multiple W's based on... I guess we'll have to get to that. But we're going to have multiple W's based on how many filters we have. But let's assume right now we have one W. We're going small and we'll get more complicated later. We get our zeros, we get this. This has to go this times W. Will that work? W is a 2 by 2 matrix. Let me look at what W looks like. W is this. Yeah, this should work. It doesn't say we should randomly initialize W. So we'll start at 0, I guess. I feel like that's a good assumption. Okay. So if I run this, okay, but let's 0.1, just so we can see something that's not all zeros. And then they want us to add the bias. The bias should be of size K. It's the smallest. I'm trying to think where you add the bias into this. I feel like it's X times W plus B. And B should equal I think just be of size kernel. So this looks correct. Okay, so now we have a forward pass of, I mean, I guess we have this. We have the forward pass. It says the sum. Oh, because each of these values gets summed into, so it'd be this. It wouldn't be that. I lied. It would almost be that. This would be it. This wouldn't be it. Why? X is not defined. I think there's an issue with our notebooks sometimes, where it will forget stuff. Yeah, okay. What should the output shape of this thing be? Probably a 2 by 2? I mean a 2 by 3. So, what I wanted. Say out equals this list. We'll have hold equal this list. We'll have hold dot append this. And then we will have out append hold. And now, if we put out, it doesn't feel right. It's because the hold should be overwritten. Oh, no. Oh. No, I'm so confused. Yeah, so I want this, and I want this. Output is currently only getting this, so it's over. No, it's not overwriting, it just, I guess it is overwriting at some point. Because at the end of this, it should go here. Take the hold, append the hold, and then go back, start, reset the holds, which does, and append this. But it's not. What do you do, and what is your area of expertise? I'm currently a data scientist at a bank. I'm on paternity leave, so I have some time to work on TPML a little more. Hoping to build it out a lot more. Area of expertise. I don't know. Nothing really. I mean, I got an undergraduate degree, more of a self-studier than anything else. I think higher, masters and PhDs are amazing, and I think, if you enjoy learning, go for it. I feel like self-studying is more my speed, just because you get to choose what you want to learn about more and more. So, like, if I find something interesting today, I go for it and I study it. If I don't, then I don't. And that's sort of, but I probably don't have much of a specialty. Enjoy teaching sometimes. That's always fun. But yeah, no real specialty. Okay. This feel like didn't use chat all stream. What is I mean, I just asked what's wrong with it. Indexing the wrong dimension. Well, it should be this. I don't want the correct version. I just wanted to know why my things weren't saving. Convolutional 3D, not 2D. Oh. Damn. The amount of things I got wrong. Let's see if I can do this. C and then 3D. In fact, it works better. 3D, CNN. I recommend any other practical book for machine learning engineers or deep learning engineering, other than the hands-on with machine learning book. It's a good question. Let me think about it. I mean, I feel like, you have to ask what's your goal. I mean, I enjoy reading some textbooks. I enjoy reading Artificial Intelligence: A Modern Approach. I forget the name of it sometimes. That one is pretty good, and it takes you, uh, from nothing to a lot. Like, it has a lot of information, and it's really interesting. It's a good read. Like, some textbooks are more well written than others. That one is, particularly well. It's written quite well. But I don't think. I don't think. I need to fix up Deep Zero. I don't think reading textbooks necessarily makes you a great machine learning or deep learning. Like, I feel like the best way to do it would be, yeah, I guess you want to understand the fundamentals. I don't know. I'm thinking because I haven't really thought much about, I guess, what would the ideal learning path be, which I probably should, but I haven't really thought about that much. I do think DeepML would fit in nicely somewhere in there, but I'm also biased. I feel like reading should be the same use as a video. You're reading to understand a concept. You're not reading, like, if I read this textbook, I'll be an amazing programmer. No, you probably won't be. Your programming skills are not going to improve. Your understanding about how certain mechanisms work might get better. So use it as that. Use it as, read something and then program it. Read something and program. I feel like that's always the ideal way of doing it. It's hard to do it like that exclusively without a project because lose motivation at some point. Like you'll read 10 pages of something and you'll be like, okay, great. What do I do now? I read another 10 pages? It's a lot. Even if you read 10 pages and then implement some stuff, it's not as cool because you're just like it has no use case. So it's hard to keep yourself motivated if you're not doing it through a project. Um, but yeah, I mean, I think I'm going to side note. I think I'm going to try to make a convolutional 3D question, 3D CNN. But I let me see. Yeah, okay. It's like I read a bunch of useless textbooks in my undergrad, and he wants to be a real machine learning data scientist, engineer, person, whatever. Um, I'd say the hard thing is usually keeping yourself motivated without a project. Like I feel like if you have a project, like let's say you're reading Artificial Intelligence: A Modern Approach, and each chapter, you come up with a project idea. You read the chapter and then you implement a little project at the end. But it has to be a project that you sort of find interesting in some way. Don't be like, I want to do MNIST. MNIST is amazing. I'm saying this as we have a bunch of labs on MNIST, but find something cool. Find something interesting that you actually find useful and interesting, and try and build it. Like, where is it? But sometimes it's hard to do with some of these books. I was going to open the RL book. RL book. RL boo. Um, so I think a fun way to, again, it's easy for me to be like, you should do this, and then me personally, I don't do this much. I probably should, and I feel like I have the benefit of being like, oh, I think this would be ideal. But it would also take a really long time to do this. Uh, but let's say I say, okay, finite Markov decision process. Read what the basic, what is this chapter talking about? Maybe even ask ChatGPT for some project ideas uh, for finite Markov decision process. See what you find interesting. Maybe try to do it without reading the chapter, and then read the chapter, and then along the way, be like, oh, hey, this would be useful. Let me implement it. Oh, this would be useful. Implement it. And at the end, you actually have a pretty good working memory of not only how things work, which the textbook should help out with, but actually how to implement it. Oh, the AI Modern Approach book? Yeah, it's a lot of theory, and it's hard. Like, I think it's a pretty. Like, I enjoyed reading it. Like, I was reading it, I was like, okay, this is pretty interesting. But it should be used as. I feel like an example that everyone understands is you go to math class, uh, your teacher solving a solution on the board, and you're like, oh yeah, this is so easy. Then you're like, this is like whatever. Then you get home and you try to do the homework and you're like, oh, I didn't understand 2% of what he was saying. Um, Same idea. This is, instead of a lecture, you're reading a textbook. Maybe you'll retain a little bit more, but you're not actually going to know how to do anything unless you actually implement it. Uh, I'd say project is the best. I'd say second to best is probably deep ML version of stuff. So you read something and then you implement. Because some people could do that. Some people could read something and then implement a question. That's sort of motivates you to understand the things. I think best. I mean, I still think best is top is probably what I said previously, just about building little projects. Second to best, I'd say, is DeepML. I'm obviously not biased at all when it comes to that recommendation. But also, I mean, me personally, like, I only built, like, I'm a data scientist. I don't build websites. I mean, we started out as DeepML Leaked, and it was a Streamlit site. And I, And then even after that, we built another version. But I built the first few versions. I built but I didn't know how to do that, and I had to spend way too much time building these things. Just because I thought this would be a good way to learn. So I do believe in this product. This is how I wanted to study. Like every day I was studying. Like this is how I came up with the idea. Every day I was spending an hour studying. For the longest time, I mean, I don't know if anyone came here to see me solve stuff. Come back tomorrow or the next day whenever I'm back on streaming. But my issue. Oh, so for the longest time, I was always coming up with master plans about how to study. Like, okay, I'm gonna read this, and then I'll do this, and then I'm gonna do that, then I'm gonna start here, and I came up with these 10-step plans that were pretty good, but then I'd start down one, and I'd be like, never mind. Like, no, I don't understand this. Let me go back to the drawing board, plan again for another 2 weeks, come back again, go, work for like 2 days, and then be like, no, never mind. And, this process went on for way too long. Then I basically started doing every month. I came up with, I'm going to learn this. And I don't care if I get stuck, or I don't care if, anything changes. I will go through this process. I will learn. Hour a day. Going down this thing. And at the end of the month, I'll tweak this a little. I'll tweak, maybe I'll be like, oh, I should have done this, or I should have done that. And that's for end of month. Right now, I'm just given this. I must finish it. I must work on it. An hour a day. A few of these went by, and then I was like, I really want Leak Code for Machine Learning. Like, I just want to read a paper and see if I understood it. That was the core idea. But I looked for it. No one made this. So I was like, I was a little annoyed that no one made it. So I needed to basically create this myself. Now I have an engineer that works with the website, which is nice for me, so I can just focus on problems. But yeah, I'd say, this is my startup philosophy. I made only one thing, and it's not even super successful, but my startup philosophy is find something you're interested in, work on it, like I'm saying, learn about it, like spend an hour a day doing it, keep going down that until you hit something that annoys you enough for you to be like, oh, I wish there was this thing, and then try and build it. I'll use UPI. I'll look into it. I don't know what that is, but I'll write it down. Okay, yeah. So we probably need to start with, probably have to get going. Okay, yeah. Okay, I gotta get going. But I'm gonna make a flow chart of things I need to do to solve this, and we're gonna go through it, and I won't stop after one step. I'll really go through this. But thank you guys so much for joining.